chemistry class. Today we will discuss the concept formal charge. Today we can see the concept formal charge. So what do you mean by formal charge? It is an apparent charge on atom of an element. So it is the difference between the number of valence electrons and unshared and bonding and non-bonding electrons. Okay, so we can see we have an equation for this. Formal charge is equal to Fc. Fc means formal charge. It is equal to number of valence electrons in a free atom of an element. In a free atom of an element minus half the number of shared electrons, half the number of shared or bonding electrons, shared or bonding electrons plus number of non-bonding electrons, that is lone pair. So formal charge is the number of valence electrons in a free atom of an element minus half the number of shared electrons or bonding electrons and the number of non-bonding electrons. Okay, so for each atom in a molecule we can calculate the formal charge. So take a look at the example, ozone. So first of all we discuss the compound ozone. Okay, ozone molecule, that is O3. It is not a compound, it is a molecule. Okay, O3 molecule. So what is the structure of ozone? Ozone, this is the structure of ozone. So this is a Lewis structure of ozone molecule, that is O3. So we can mark the number, we can give the number to oxygen atom. This is the first oxygen, this is second oxygen, this is third oxygen. Okay, this is first oxygen, second oxygen and third oxygen. So we have to calculate the formal charge of each oxygen atom. Okay, first of all we can calculate the formal charge of O1. Okay, formal charge of oxygen 1, first oxygen. Okay, formal charge of first oxygen. So how can we calculate? First of all you should know the number of valence electrons. So number of valence electrons in all the oxygen atoms are same, that is 6. Okay, in all the case it is 6. 6 minus. Okay, then bracket half into number of shared electrons or bonding electrons. So this is the first oxygen. We are considering this is the first oxygen. It has how many shared electrons? It has 6. This is 2, 4, 6. 6 shared electrons. That means number of electrons in the bond. That is shared electrons. That means shared pair. Okay, in one pair you have 2 electrons. So total 3 pairs are there. So therefore 6 electrons. That means half into 6. Okay, then plus number of non-bonding electrons. In first oxygen we have only one lone pair. That means 2. In one pair we have 2. Therefore only 2. Okay, so 2. Now we can calculate. That is 6 minus 3 plus 2. That is 6 minus 5. That is equal to 1. Plus 1. Okay, plus 1. Okay, plus 1 is the formal charge of first oxygen atom. Clear? So here 6 is the number of valence electrons, then half into number of bonding electrons. So 2, 4, 6. When you consider this oxygen, these are the bonding electrons. 1, that means First bond, second bond, third bond. Total 3 into 2, 6 electrons are there. Plus 2. 2 is a number of non-bonding electrons. So lone pair is there, lone pair. Okay, so plus 1 charge. Now Fc of oxygen 2. Okay, that is equal to number of valence electrons. That is always same. 6 minus bracket half into. This is a second oxygen atom, second oxygen. How many lone pair of, how many bonding electrons are there? So only 2 bonds are there for this oxygen. Only 2 bonds are there for this oxygen. So 2 to 4 electrons. 2, then 2, 4 electrons. Plus number of lone pair of electrons. Here we have 2 lone pair, therefore 4 electrons. 1, 2, 3, 4. Number of non-bonding electrons, 4. Okay, 4. That is equal to 6 minus 2 plus 4. That is equal to 6 minus 6. That is equal to 0. Okay, 0. So second oxygen, 0. Okay, so here we can see that number of electrons 6. Then half into 4. 4 number of bonding electrons. Then 4 is number of non-bonding electrons. 2 plus 4, 6. Therefore 6 minus 6, 0. Then we can see the Fc of oxygen 3. 6 in minus half into 6 is common, that is number of valence electron 6 minus half is also null. Here half is there for unshaded electron, half into, so half for shaded electron. Here we have only one bond, that means 2, that means only 2 shaded electrons, 2 plus number of non-bonding electrons 1, 2, 3, 4, 5, 6. 6 are there, number of valence electrons. Okay, therefore 6 minus 1 by 2 to 1 plus 6, that is 7. That is 6 minus 7 is equal to minus 1. Okay, minus 1. Clear? So here 6 is number of valence electrons, then half into minus half into number of unshaded electrons. That is number of bonding electrons. Only 2, one bond is 2. That is half into 2. Plus 6 is number of non-bonding electrons. That is 1, 2, 3, 4, 5, 6. This is non-bonding. It is lone pair. 6. Therefore 6 minus 1 plus 6, 7. 6 minus 7. Okay. 6 minus 7. Then what is that? Minus 1. 6 minus 7 is minus 1. So when you calculate the charges of all the oxygen atoms, first oxygen, okay, 1 plus 1. Then second oxygen, 0. Then third oxygen, minus 1. Total 0. So charges of all the atoms in the molecule is 0. So this molecule is electrically neutral. Okay. Or we can represent like this. Charge of first oxygen is positive and second oxygen 0, so no charge, and third oxygen is negative, so plus 1 minus 1 0. Okay, so formal charge is the number of valence electrons in a free atom of an element minus half number of shared electron plus number of non-bonding electrons. Okay, that's all about the formal charge, and we can see one more example of formal charge. We can see one more example of formal charge. So here we can see that we can take the example of CH4. CH4. When you take the example of CH4, carbon. This is the structure of CH4. CH4. Okay. So formal charge of carbon is equal to number of valence electron in free atom 4. Okay. Number of valence electron 4. Then bracket minus bracket half into number of shared electrons or bonding electrons. So 1, 2, 3, 4. 4 bonds. So total 8 electrons. So we can calculate like this: 2, 4, 6, 8. So half into 8 plus number of non-bonding electrons. There is no bonding electron. There is no lone pair. So it is 0. Okay. So 4 minus 4, that is equal to 0. Okay. 4 minus 4, that is equal to 0. Formal charge of carbon is 0. Now we can calculate formal charge of hydrogen. Formal charge of hydrogen. Okay. So number of valence electrons of hydrogen atom, it is 1. Okay. Bracket half into minus bracket half into number of bonding electron of hydrogen. Okay, that is 2. So 2, then plus number of lone pair of electron or number of non-bonding electron. There is no non-bonding electron, so 0. So 1 minus 1, that is equal to 0. So all the hydrogen atoms are equivalent. So in all the cases of all the hydrogen atom, the formal charge is 0. So formal charge of carbon 0, formal charge of hydrogen 0. I think it's clear. That is all about the formal charge. Okay. Now we can move on to the next topic: ionic bond or electrocovalent bond. Ionic bond or electrocovalent bond. Okay. Ionic bond. So here we can discuss ionic bond. So we have already studied ionic bond in your lower classes. Ionic bond is also known as electrocovalent bond. Ionic bond is formed by the transfer of electron from one atom to another atom. Okay. So the atom in this case sometimes gains electron or atom loses electron. The atom which loses electron becomes positive, and the atom which gains electron becomes negatively charged ion. So here you need positive ion and negative ion. Positive ion and negative ion. Here the bond is formed by the transfer of electron from one atom to another, and in this case one atom loses electron and it becomes positively charged ion or positive ion, that is cation, and one atom gains electron and that atom becomes negatively charged ion, so that is cation. So positive charged and negatively charged ions are there. Okay. And there exists a force of attraction between this positively charged ion and negatively charged ion. So this ionic bond is defined as the electrostatic force of attraction between the oppositely charged ions. Okay, it is the force of electrostatic force of attraction that holds the opposite charged ion. Okay, എന്ന് പറഞ്ഞാൽ രണ്ട് ഓപ്പോസിറ്റ് ചാർജ് തമ്മിലുള്ള അട്രാക്ഷനെ ഹോൾഡ് ചെയ്യുന്ന ബോണ്ടാണ് എന്ത് ionic bond. So it is defined as the electrostatic force of attraction holding the oppositely charged ions. Okay. That means there is a attraction between positive ion and negative ion. Okay. Then there are two conditions for that. For the formation of ionic bond, one atom should lose electron and another atom should have a capability of gaining that electron lost by the another atom. Okay. One atom should lose an electron and another atom should have a capability to gain that electron lost by the another atom or the other atom. Okay. So we can see one example: formation of NaCl, sodium chloride. Sodium chloride. Okay. So atomic number of sodium is 11. Electronic configuration 2,8,1. This is electron dot structure. Na1 structure. It loses one electron and becomes Na plus. So now it completes its octet. That means it has completed its octet. Okay. Then what chlorine does? Chlorine electronic configuration. Atomic number 17. Electronic configuration 2,8,7. It means 2, 4, 6, 7 electrons are there. So chlorine needs one electron to complete its object. So it gains the electron lost by the sodium. So it becomes like this: 2, 4, 6, 8, and electronic configuration 2,8,8, or it is Cl minus. We can represent Cl minus. Okay. So By losing one electron, sodium has completed its octet, and by gaining the electron, chlorine has completed its octet. Or we can represent like this: Na plus Cl minus gives Na plus Cl minus, like this. Okay. So there is a force of attraction between sodium Na plus ion and Cl minus ion. So we have seen here positive and negative ion, like that. Here we have one Na plus positive ion, Cl minus negative ion. So this is Na plus positive ion is known as cation, and Cl minus negative ion is known as anion. Okay, that is the example of ionic bond. It is also known as electrocovalent bond. It is also known as electrocovalent bond. Electrocovalent bond. Okay. So ionic bond is formed with a transfer of electron from one atom to another. So it is the electrostatic force of attraction holding the oppositely charged ion. Okay. That is all about today's session. Thank you.